Hello, Mrs. Wagner here. All right, so we are going to be doing lesson 3. So you have a new notebook, and this notebook is all about physical and chemical changes. So if you recall, the last thing that we kind of worked on was physical properties, chemical properties. So we'll just review real quick. Physical properties are those properties that can be observed about a substance without changing the substance's identity. So for example, if we're going to calculate a substance's density, we can do that without changing what the substance becomes, or if it becomes something new. That does not happen, okay? It stays the same substance. So we can figure out the density of water, which is 1, and when we calculate the density, we are not changing it into something else. So it's still water, okay? If we are going to observe malleability, which is the ability to bend and shape metals such as aluminum, I can do this. I can observe that it's malleable without changing its identity. It's still aluminum, okay? So those are physical properties. So we looked at a lot of different physical properties such as luster, malleability, texture, transparency, a whole lot of physical properties. Then there were chemical properties, and we really only looked at 2. They were reactivity and flammability. So when we observe reactivity, if something reacts with something else, we are actually changing its identity and it becomes something brand new. You have new substances once the reaction occurs. So probably the most obvious one is rust. When iron comes into contact with oxygen, when it gets wet, then it can form rust. That iron and that oxygen, something happens there where then we get rust, which is a new substance, okay? Then flammability is another chemical property. So if something is flammable, such as wood, and if we were to burn wood, we don't have wood anymore once it burns. It becomes something new. You are left with ash, you are left with carbon dioxide gas, and you are left with water as well, okay? All right, so this unit is taking a look at a little bit more detail and in depth the chemical and physical changes. So changes that we can make on matter, and are they going to be physical changes or are they going to be chemical changes? So remember, when we observe physical properties, we can change something in a physical way without changing its identity, okay? Whereas if it's going to be a chemical change, then we're going to be creating something new, okay? And we will have some observable kind of effects of that. We might have color change. We might have a different odor, or we might notice an odor that wasn't there before. We might see the presence of gas or bubbles, which would indicate maybe a gas, and there might be some heat that is involved. So we might feel heat from that chemical reaction, or maybe it feels a little bit cooler, okay, from the chemical reaction. All right, so we're just going to kind of get into it and do a few, in this unit, or this lesson, I should say, we're going to do a few examples and some lab investigations to determine if we have a physical change or if we have a chemical change, okay? All right, so the very first one, we're on slide 3 here. This is just kind of a pre-lab activity, just to kind of get us looking at the difference between physical and chemical changes. Okay, so we're going to use a mortar and a pestle, which is something like this. All right, we'll be crushing some things. A sugar cube, which you can't find anymore. So you have sugar cube on there, but instead I have a very hard marshmallow. So that's going to be our sugar cube. You can't find sugar cubes anymore. So they have sugar packets. They don't make cubes anymore. 2 pieces of aluminum foil, an ice cube. So that's what we got going on today. Okay, so directions part 1. In the mortar and pestle, we're going to take an ice cube and we're going to crush it. And then we'll do the same thing with a sugar cube. okay? And then we'll answer the questions that we see on our slide deck here. All right, so I have our little marshmallow here, so just kind of make some observations. What do we notice about it? I can tell you it's hard, okay? So I'm kind of squeezing it. It does not want to squish, okay? All right, so I'm gonna pop it in here, and I haven't tried this yet on my own, but we're gonna see if I can get it to crush. Couldn't squeeze it. Ah, yeah, this is good. All right. Yep, this worked out really well. So now I'll show it to you. All right, so what are some things you notice now? What did we change? All right, we did change it. How did we change it? Okay, so it doesn't look the same. Is it still a marshmallow? Okay, now the ice cube. So we're gonna do the same thing with the ice cube. So here's the ice cube. Okay, oh, it's dripping. All right, we're gonna stick it in here and I'm gonna crush it. That wasn't too hard either. And there it is. Okay, we changed it. So it's a little different. Okay. All right. Now, let's take a look at our questions here. It says, when you crushed the ice, was this a physical change or a chemical change? Now remember, when we observe a physical change, we can make a change on the substance, but as long as it remains the same substance, it's a physical change. So we need to ask ourselves, is this still a marshmallow? We did change it, okay, but is it still a marshmallow? How about the ice cube? We did something to it, okay, we crushed it, we changed it, it looks different now. Is it still H2O? Okay, which is what ice is. Is it still H2O? All right, okay. And then number 2, when you crushed the sugar cube, was this a physical change or a chemical change? Again, you know, did we change them in a way that changed the identity, or did they remain the same? Okay, one thing we forgot to do was our hypothesis. So let's take a look at that. So if a substance goes through a chemical change, then the substance will, we could put the word change in there. We could say made into something, what? All right, what would you put in the second parentheses? And then I talked about something either being given off or absorbed. We might feel it being warm, or we might feel it being cold after the change, okay? So we're really gonna focus on chemical changes here. What will happen in a chemical change to substances when they go through chemical changes? What can either be given off or absorbed, okay? All right, so go ahead and fill those in, answer those 2 questions, and then we'll move on to the next slide. All right, so this is part 2. So now what I'm gonna do is I'm gonna take our ice, and I'm gonna place it into, actually I have another ice cube here. And I'm gonna place it into the aluminum boat. And I have a candle, and I am going to light the candle, and I'm going to hold the ice cube over the candle and see if we have any changes there, okay? And then we'll do the same thing with the marshmallow, okay? All right. Come on. Oh, yeah. Of course, here we go. What's happening? There we go. All right. Took way too much effort there. Okay. All right, so I am going to place this. Now I can't set it on top, obviously. It'll snuff out the little flame there. So I'm going to let this go for a little bit and we'll come back and see what happens. Okay, a few minutes has passed and let me just share with you here what we've got. So as you can see in there, there's some water. Oh, okay, got a little bit of puddles of water and our ice cube is smaller. Eventually, we could probably get it to disappear or become all water. Okay? Okay, so we changed the ice cube, but is it still the same substance? And how do we know? Okay? All right. Okay, so that's that one. Now the next one is going to be the crushed up marshmallow. So I'm going to just pour that right in there and see it in there. Okay. I'm going to place this one over the candle. Okay. We'll give this some time too. So I'm going to let this hover over the heat of the candle and then I'll show you after a few minutes of time. Okay, so here we have a change, right? We changed our marshmallow. Looks like we have a color change. I can tell you I can smell like toasted marshmallow, like if it were over a campfire. The substance looks completely different. It's bubbling, which might indicate, oh, and I'm seeing some, can you see some smoke there? So it's not a gas, I mean, that's smoke. So that's coming from the marshmallow. So we've created some new things here. We have brand new substances. This is not a marshmallow anymore. We have smoke. Okay, so the presence of a gas tells us that this might be a chemical change. We have a completely different substance. That's not a marshmallow anymore. Okay, it's a little bit crustier. If I were to try to peel it out of the tin foil, it's kind of crusty. Okay, so that's something brand new. Okay. Okay. All right. So number 3, when we heated the ice, was that a physical change or a chemical change? What's our evidence? Now we did change the ice cube. It does look different. It has some different properties. Okay, but the properties that stayed the same are the ones that identify it as H2O. So its melting point is still the same. Its boiling point is still the same. It's still the same substance. It's still H2O. We didn't change the identity of it. Okay, we changed something else about it. And then number 4, how about the sugar cube? Was that physical or chemical? Well, we saw some different things going on there. We saw smoke and we saw a color change, and I said that there was like an odor that I could smell. We toasted marshmallow. You probably all had that toasted marshmallow smell before. So is that a physical change or a chemical change? Well, the things that tell us that it might be a chemical change are the things I mentioned. The new substance, okay? That's going to tell us right away, oh, we created something new there. It tastes different than a marshmallow. It smells a little bit differently, and we created a gas, okay? So those are some things that are evidence that tell us that it might be a chemical change, okay? All right, so that's it. That's slides 3 and 4. Go ahead and make sure those are completed, and then we'll move on to the next few labs.